in 15 minutes, really what I'm going to try and do is kind of throw the balls out, as it were, in terms of kind of put some things out there to stimulate discussion. The topic of the future of work and the impact of AI on that is massive. I can think of at least 15 different elements that will all be kind of hour and a half, kind of, this is what's going off. So I'm going to pick some things deliberately at the edges to kind of stimulate some thoughts that touch on many of the issues that I kind of have to deal with day to day. A little bit about me so that you know where I'm coming from in this. I was born at a young age. My background was an engineer. You can tell that because even as a child, I'd taken things apart, breaking them, trying to work out how they worked. Spent most of my kind of early career working with advanced technologies. Got more and more interested in the wetware side of things, these kind of fluffy humans that broke everything that we built, and went back and did a psychology degree. And spent a lot of time working in areas of what's called perceptual psychology. So that's really how we perceive the world and how we interact with it, which turns out to be a kind of a fascinating area and kind of very relevant for what happens with AI. By kind of historic background, my father was an engineer, worked in the automotive industry, and that's kind of where I'm going to start off with a small story that's not, hopefully not too alarming, but actually probably frames much of this discussion. I'll be interested to see how many of you are familiar with it. If I say the 25th of January 1970, does that ring any bells for anybody? Burns Night. Oh, look, here we go. The first battle of the technology, and this will be part of what I talk about here, is making that go to the next slide. Is that going to do that for me? Or is that just died spontaneously? Okay, there we go. Start from current slide. I will talk about this general pattern later on, but normally I dutifully save my slide with version numbers into your engineering style, so that if anything goes wrong, we can go back to the previous version. Of course, today was the one day I didn't do that, so what happened on the way in on the train as I'm looking at the slides? Screen of death on the Mac. So if I look surprised when the slide comes up, that's because I'm surprised by the slides come up. But more seriously, this is kind of a date to remember in some ways. And really bizarrely, it's actually in the Guinness Book of World Records for reasons that will seem even more odd in a minute. And it's also interesting, nobody really knows the name. Know the name Robert Williams? Why hold the records?
It's definitely not 45, that's wrong. Unfortunately, Robbie Williams.
Well, this particular Robert Williams in 1970 was 25. And Robert Williams worked for the Ford Motor Company. And the very tragic record that Robert Williams owns is he was the first person to be killed by a robot.
Fanuc swung round and
yeah, pretty much decapitated him. Pretty instant. He was working in a pod, in a cage, and yes, the robot didn't have any safety mechanisms, swung, and that was the end of him. Very interesting because it's effectively a murder case that nobody was ever charged for. The Ford Motor Company did pay out about 10 million, I think, in compensation, which at the time was a phenomenal amount of money. Quite dramatic, but I make the point because the kind of net result of that was that robots work in cages, basically. I mean, if you, up until a few years ago, if you go into a factory and you see robots, they'll be working in cages. And nobody goes in the cages because they're stupid. One of those unique human characteristics. Interestingly, about 2 years ago, 2 companies reintroduced robots working in open spaces. One of those was Volkswagen. So again, I make the point, so it's kind of interesting that even in something simple about robots, instantly we kind of hit into an interesting area around kind of ethics. And interestingly, with AI, it's basically inescapable. And some of the applications that I'll talk about in the workplace, you'll kind of see why it's inescapable. it's also interesting that with robots, with physical robots, you had this idea of it being in a cage. You could separate the domain of impact. With non-embodied intelligence, so with kind of software intelligence, there isn't a cage today. And I kind of make the point because right now nobody said, well, where's the cage for AI? How do you kind of bound and control what it does? Nobody asked that question with robots. After 25th of January 1970, they did very, very quickly. It's a massive media uproar, as you can imagine. So, you know, there is a history to humans working with technology, and this is probably the seminal event in that, and it will drive some of the discussion. That said, obviously technology can do very good things as well, but there's a kind of question of kind of where we divide. And a lot of the discussion about AI, particularly in the workplace, is how we relate to it and how it changes our behaviours. And that has become the dominant factor. It's really interesting this week that Google open sourced their learning engine, their AI engine, effectively, which is very generous of them, which also tells you something. It basically tells you that there is no commercial differentiation in the AI engine itself. Right? The smart stuff that's going to happen with AI is how you apply it and how you contextualize it. It's a really, really good engine, the one that Google have released, by the way, if you want to go and play with it. Relatively usable. It's very generalizable, so you can do things like train it to detect noise and pick out speech. It's also the same engine that they use for kind of auto-reply and junk filtering in Gmail. So it's a pretty broad trainable engine that's there, free. If you don't use it, you just need a computer to run it on.
To redo your link to the presentation screen.
Oh, right, okay.
Sabotage.
Sabotage by technology.
Artificial intelligence, Benjamin.
It does it about once per presentation at slide 6.
Could not
There's obviously something going on.
Yes. Well, is it going to come back?
It always doesn't. It always doesn't. You've got the little.
It's got a different code than you had before.
Oh, it has 1, 2, 5, 4. So I just rerun it, do I?
Yeah,
well, this is so funny.
Code in it as well.
You're just trying to get the true phone name up there again.
Yeah, it's the fast-paced broadcast plug. Buy, subliminal.
Well, if it doesn't come up, yeah. So it's doing all sorts of pretty things, which is promising. If it doesn't, that's fine. Good luck finding the license.
Do you want me to try while you're talking?
You can try while I'm talking, and that's fine. And while you do that, I will actually talk to something further ahead in the presentation, because this is a perfect proof of it. So back in the 70s, at that point in time, there was a massive concern that all of this technology would lead to huge unemployment. Robots would come, would take everybody's jobs, it would be the end, revolution, etc. The interesting thing is something that economists call the productivity paradox. So if you think about it, if we take people and you make them more efficient, which is really what technology is doing, so if one person can do 5 people's jobs, that should be 4 people out of work, right? Nice simple logic. That's kind of how economics go. The reality is that the predictions of technology for kind of robots and very early AI is that there will be an increase in productivity, and again, depending on whose figures you take, 3 to 5%. So there should have been people who became unemployed. What actually happened? More people got employed. The other discussion that was probably more earlier from the 60s was this idea that we'd have huge amounts of leisure time because of all this great technology doing these things for us. Did I miss the memo on that one, right? So we have less leisure time now as a generation than the previous ones before. So there's this really curious thing around technology that, although it should improve productivity, for reasons potentially related to this, it decreases it. And more specifically with information technology, a number of studies have been done over the last decade, and all of them have found that where the business has spent money on advanced high-tech stuff, productivity hasn't gone up. So that seems to be kind of...
Really?
Oh, it's even worse.
Shutting down.
Yeah.
That's what I'm interested in.
Oh, is that Safari, is it? Chrome should be here. So this is kind of curious, and again, the place where it's been studied, there have been most academic studies, is in the car industry around robots. And again, the interesting thing there is, again, obviously you would think you put a robot in and you automate a task that one person's going to do more stuff. Kind of logical thing with technology. What happens is people do become more productive, but the number of people doesn't go down. What happens is the number of robots goes up. And it starts to get very counterintuitive. And the kind of latest thinking of this is what's called reverse causality, which is that as opposed to robots and kind of high tech coming in and making people more efficient, what's actually happening is that as people get more efficient, they bring in robots and technology. So the link is kind of almost the opposite way around. Really bad, right? Because you think about it, if you're spending all this money on all this high-tech stuff, you know, something's got to move somewhere, but what's happening is something doesn't move. We just kind of do more of the same. That's fine if it doesn't make it something like that. Oh, look.
Your robot has worked.
Look at that. Okay, I'll leave it there. That's cool. And of course, now I haven't got my mouse.
Who knows?
No.
So kind of back. So there's this productivity paradox, and it's recurrent. It doesn't matter what you look at.
Yes.
Yep. No idea what it's doing now. Oh, okay. Whatever. So the other kind of park that one. So this is this issue.
Oh,
Yeah,
it's running on a show.
Oh, it's doing its own thing. Dumb apes, slave to machines. That moves differently than that, which is so much fun. Okay, whatever, touch nothing. So one of the most common objections to AI in the workplace is, isn't it going to kind of carve out all of the jobs? And Oxford University did some research, a couple of management consultants did some research, and they had this idea of hollowing out the middle. Has anyone heard of this one? So the idea was that there'll be less and less of the kind of middle management jobs, the kind of middle kind of rump of what makes up our economy, the US economy, as technology came in. What's happened is, in businesses that have invested in AI or high tech, the opposite's happened. They have more middle managers. So again, it's kind of back to this interesting productivity paradox, kind of reverse causality thing. It seems to work the opposite way than we'd expect it to work, and nobody really understands why. It's keeping lots of economists occupied. There is a general point in that I'll come back to in a minute, right? Kind of how we understand organisations and how they work in an economic context. Park that there, come back to here for a minute. So Moore's law, obviously we kind of have this all the time, and this is still one of my favourite all-time things, the 5 meg hard drive from 1956, and the quote from one of the magazines back a decade ago saying that we might see 2.5 inch 40 terabyte drives for as little as $40 by the end of the decade. I think we're kind of well on target for that one easily. Right? Computing power has become cheaper and cheaper. Storage has become cheaper and cheaper. So we kind of have this kind of era of big data. We have huge amounts of information and huge compute power. So magic should happen, right, with AI. There should be all sorts of exciting things that we should be able to do with that to realise value. And we started to talk about that in the area of AI. I'm going to use a real but actually silly example to kind of make a point about complexity. So in terms of how you approach things with computer systems, in my environment, we talk about emulation and simulation a lot. We make a distinction between those, which I'll explain. So emulation is the idea of recreating something by basically doing it by exactly recreating the properties of that system and its inner workings. If we apply emulation to the human brain, that becomes quite interesting and quite fun. The kind of 101 on the brain is that it has neurons, and that's great, and we understand them a little bit like wires sometimes. And back in the 80s through to the 90s, a lot of what was done with AI was done with neural networks, with effectively emulating what the brain did to recreate intelligent systems. And it turns out you can make some pretty neat systems, really, really good for kind of visual recognition type tasks, teaching robots to be able to kind of pick up nuts and spot defective nuts, really, really good. So scale that up and simulate the human brain. Sounds like good fun, isn't it? And that's an actual project in Europe in the academic domain at the moment. However, it turns out that this kind of simple model that we have of kind of what the innards of the brain look like. So this is, we have kind of dendrites and axons. So this is effectively signals go down electrically through magic that biologists are still arguing about exactly how it works, out to axons. And then we have neurotransmitters that you hear so much about the brain that then pass that signal on. So the brain does this kind of clever stuff of switching between electricity and chemicals, and that leads to a lot of its quite unique properties because those chemicals run out. So what you eat changes how you think, which is an interesting one. If I actually know, as soon as we're kind of, so stand up a second. It's a really silly exercise to demonstrate human brain and talented AI, right? So if you do a Superman pose, so legs slightly apart, arms like that. Feeling good? So good?
Great.
If you now make decisions, you'll be overconfident and over-aggressive in your decision making, just from doing that. Because what's happened through doing that is you've unleashed a whole bunch of really exciting hormones in your brain, a little boost in testosterone, and it's changed how your brain's wired because it changes the environment for the neurons. So literally just doing that changes your decision making. So if you sit down, that's a nice stretch, wasn't it? And do the whole kind of, put your legs together and put your hands on your legs like that, put your head down and look like that. Right. Can you kind of guess what's happening to your decision making now? Right. So, the point of that is that a lot of the approach to how we build AI in the workplace is what in psychology we call very cognitive. It's this idea of disembodied intelligence. So thinking about robots, kind of embodied, moving around, to disembodied, just kind of this thinking that happens in abstract to everything else. Our thinking doesn't happen in abstract to our physiology. Right? Because of the way that our brain is constructed, our physiology, what we've eaten, how tired we are, the pheromones around us, our posture all change how we make decisions. So, back to emulating the brain. So this should be fun. Each neuron tends to connect to, and it varies, up to around 10,000 other neurons. So for those people who are kind of networky, if you want to simulate the brain, the kind of best project that's done this simulated 1.73 billion nerve cells connected to 10.4 trillion synapses. It's quite big. That's less than 1% of the brain. Less than 1%. Okay. This is the K-class computer. As you can see, it's not really suitable for your laptop case as such. The simulation took 1 petabyte of RAM. So again, this is 1% of the human brain. And just to add insult to injury, if you're going to use this for decision making, it took 40 minutes for that set of toys to simulate 1 second of 1% of the brain. Okay, that's fairly mind-bending. How many people, kind of on average, in some of the organisations around here, you know, kind of we're talking thousands of people. So if you wanted to kind of use compute to emulate the intelligence in an organisation, that's a lot of computers. Now, again, we've got Moore's law and it's going up in this trajectory, but I'm still probably going to be buried and decomposing by the time we can run that sort of simulation in real time. 2053.
No, it's much sooner. What we say.
Well, so there's a problem here, and this is what happens every time we do neural simulations. So you'll notice here that I kind of put a note that used 24 bytes per neuron. If you go back to when I started playing with neural networks, we would use a few bits because we thought neurons were switches. Because you thought, oh yeah, you fire a thing in and it fires out the other end. It turns out that neurons are phenomenally complicated. They don't just fire forwards, they can exert back pressure through the network as well. So actually a neuron can effectively push backwards through chemical mechanisms to stop other parts of your brain firing. They can also wrap around and suppress each other. So what does a neural network look like? A little slice under a microscope looks like this. Is literally, imagine somebody took all of the cables in the world and kind of threw them down in a pile. That's what it looks like. And each time academics do a kind of neural network simulation, what we discover is that the neurons work in a slightly more complex way than we thought. The latest fun and games is that there are a set of scientists who think that there are actually quantum mechanisms going off within that as well. Now, I don't know lots about quantum mechanics, but I do know that whenever you mention it, that the people who kind of work at how much compute power we need for things, you talk about simulating it, all start kind of fainting, and the t-shirts start, the vendors start turning up with free t-shirts, which means you're going to have to spend a lot of money. So, yeah, I think current predictions, it will happen 30, 40 years. I think what is more likely is that as we get better at doing the simulations, that we realise that actually it's a bit more complicated than we thought. Because these are actually relatively crude simulations compared to what a kind of neuroscientist might say there. And so these two worlds got to come together. So let's not do that. Let's do something else. Let's do simulation. So emulation in my world means that you have to understand exactly how the internal mechanisms work and you recreate that. Too hard. Try again. So what we can do is do simulation. This is my son, Nathan. Nathan is simulating a cow. It's the best illustration I can give of simulation. So with simulation, we say, we don't have to make an exact replica. We make something that behaves that way. And that was kind of the next kind of role of AI and how we might use AI in business was, well, let's simulate what a particular subfunction would do. It's much more efficient. It can be very, very effective. But you kind of notice is if you kind of look at it closely, you can tell it's not really what it's meant to be. And that becomes particularly important in the context of business culture, and I'll come back to that one in a minute. So simulation, we can do some quite clever things, but simulation still requires that we can describe how the system behaves. And that's great for simple self-contained problems. If you kind of go to your team in your business and I say, right, what I want you to do is just to write a document for me that comprehensively describes what the team does. I don't need to know how they do it. Just describe the kind of the inputs and the outputs, which bits of the business they work with, and what information they exchange with the business, and how they decide which bits of business to work with. Would everyone be happy to go off and do that? It was really quiet. All right. Let's say that you did manage to do that successfully. And there's a huge opportunity for you in consulting for SAP, by the way, if you would do that. If you put that in a safe or save it onto your computer and come back in 4 weeks, would it still be valid? And so simulation works really well for systems that have known characteristics that we can document and that don't change too much. That absolutely doesn't describe any business that I have ever worked in. Yeah, there are some exceptions to that. So as a technique, we need something more sophisticated in simulation if we're going to use it in business, because it just doesn't work. And a lot of software try to do simulation to try and get into the business process, and it always ends up kind of out of date. It doesn't represent it. We also have what we call in business informal mechanisms, which is a really polite way of saying, when you ask people how the business works, they tell you X. When you look at it, it's actually Y. We call those informal processes. It's a polite way of saying something that Dr. Gregory House said. I use this as an illustration, kind of challenges around AI. I'm doing awfully for time, probably.
Don't worry. We can, please, carry on.
So this is, I don't know what House? just love it. It's very dark. Yeah, the lead character, Gregory House, has this thing that everybody lies. Again, in social psychology, we call it socially desirable responding, which is a very polite way of saying everybody lies. Which is if you ask a human being a question, they will tend to answer it in the way that they believe that you want to hear the answer. And it's not deliberate dissemination, it's actually a really important mechanism for not getting killed, historically. We have lots of behaviours that are to do with social cohesion. So again, most AI thinks cognitively, thinks about individuals. If you look in the business context, what goes off is social. So that network of brains has to be kind of treated as a network of brains because business is a social activity for the most part, certainly knowledge work, which is kind of where most of us work. So here's the AI challenge. This is kind of 2 levels of lie, this statement. Has anyone kind of got the second level? So the second level of lie is this is the script of an actor. Right? He's not a doctor. We all know he's not a doctor when we think about it. As human beings, we do simulation all the time. And in psychology, we call that theory of mind. So the way that we work in business when we interact is we have a model of how the other person works. We also have a model of how we believe the other person thinks that we work. And in fact, we have a model of how they think we think they work. And it can go a couple of levels beyond that. Right? Social interactions are phenomenally complicated because what our brain is doing, and get this one as a computer science thing, is it's running a simulation, if you like, of the brain of the other person. And we have to do that in order to be able to communicate. Now, if you think about it, computers that communicate both run the same protocol. If they don't speak the same protocol, they can't work. So in essence, they're kind of almost running a simulation of what's happening at the other end. So our human brains kind of do a version of that. So all the time, when we interact, we're using a lot of our, again, it's a very vague phrase, mental capacity, really dangerous phrase, because we use all of our brain all the time. Brains are really expensive, right? Now, from an evolutionary point of view, if they weren't useful, we wouldn't carry them around. To that point, getting to a level of AI that we could use in the workplace, they could read something like this and go, I understand what that means, but I understand that this is an actor saying that, and therefore it's not necessarily true because it's somebody reading a script. There's a massive level of complexity. But in business, we're doing that all of the time. When we interact with a customer, when they tweet something, right? We're doing that level of what do they think that we think they're saying when they say that. Call it signaling, social signaling. There's not just the raw communication going off. There's actually a negotiation of meaning, which is kind of how we work. Another silly, funny one, right? We know this is not actual instruction, right? As a kind of side note, we know people are probably familiar with the Turing test. For me, the Turing test is when a computer laughs. I think at that point we probably got there. But more seriously, this kind of really sophisticated level of AI, where is that kind of relative to the workplace? IBM used to have big blue do chess competitions. Anyone remember that? Very famous. They don't do that anymore.
No, the machines always win.
The machines always win, and there's another reason that they don't turn up anymore. And I asked an IBM person, and this was the answer they gave me, and somebody else asked them, and they gave them the same answer and said at the conference, so I feel like I can say it now. They don't turn up because it's expensive. Right? Compute, like a K-class computer, is expensive. So in terms of people going, well, AI is going to come and take our jobs and we'll be redundant, how much for a laptop? Depends on the spec. Should we spend £1,000? Does that sound fair? We'll write it off over 3 years, we'll call it 300 quid. How many watts of electricity? Like a couple of hundred now, aren't they? Right, that's another 200 quid a year to run the thing, so now 200, we're now £500. Right? You might want a bit of software, let's have £100 to spend on software. Right, so we're now at £1,000.
Open source.
Okay, you can have the £100 back, we'll stick with the 500. Even at the 500, you're above the annual salary.
Oh.
That's fine. You're above the annual salary of a third of the planet. So the kind of curious thing is that even for folks around here on probably slightly higher salaries than that, actually compute power is still really expensive. So kind of immediate future, AI is really, really compute intensive for most of it. And that makes it expensive. And actually, you and I are surprisingly cheap. So there you go, a bit of job security through being cheap. But it is a serious point, in terms of how the technology comes in. It's only going to come in where it makes economic sense. So where does it make economic sense? Help me. So yeah, we're not going to do emulation. Simulation's difficult. What are computers doing really, really well right now that's kind of disruptive in the workplace that will kind of lead us into a discussion that we should do? First thing is around large data sets. There's something called the hedonimeter, which people might see me use Twitter. It basically takes all of the tweets on Twitter, parses them through natural language processing, and works out sentiments. How happy are people today? Right, for a human to do that, that's just genuinely impossible, right? But a computer can take all of those tweets, analyze the sentiment, and give you a beautiful graph that shows you how happy or unhappy people are. Right? So that level of kind of raw pre-processing large data sets, different levels of AI do really, really well. And what's working really, really well now is being able to do some kind of forward prediction from that. Now, again, I'll kind of bracket that. They're very good at being able to say, this is the pattern we would expect, which helps a human being go, oh, actually, what's happening is not that. It turns out that predictive analytics, which is what a lot of people talk about at the moment, is really, really problematic. And the reason that predictive analytics is problematic is something called overfitting, which is basically, as soon as you get a really good model, it's broken. What happens is the model trains itself on stupid things. So an example from a previous business, we've got a really good model for analysing audio. It's fantastic. But what it had actually done in terms of analysing the quality of the audio was there was a particular background noise it trained itself on. Because in the data sets, all of the poor samples happen to have a particular bit of background noise. Okay, and so the very, very clever AI algorithm had figured out that wherever I hear that noise, this is a rubbish data set. However, that background noise was nothing to do with whether it was good or bad data, but it just happened to be there. And so there's this weird paradox that the more data you train AI on, actually the harder it is to test whether it's doing the right thing. And so whilst you can say this set of outputs means this result, to use that, for example, for kind of pre-crime, the whole kind of minority report thing, just because everybody exhibits A, B, and C is a criminal, doesn't actually mean that everybody exhibits A, B, and C as a criminal. There can be other ways to get to that same set of data. And so turning that backwards is really problematic. The other kind of interesting thing is that we get all these great predictions. One of the other ones is in the medical space. The algorithms are working fantastically well now for really complicated things like comorbidity. So this is when you have a primary medical condition, sometimes a second condition will crop up. And oftentimes that's actually kind of what finishes you off. And so that's a very complicated problem for a human, right? Dealing with multiple conditions, and particularly then administering drugs and managing the side effects. Computers can do that really, really well. Unfortunately, the kind of net output is it just tells you how likely you are to die, which is not necessarily a helpful output. Right? And that leads to some difficult discussions, which is, okay, I've got that data now. If I've got two patients and I know one's really likely to die and one's not, and I've got a limited budget, who do I treat? And that sounds hypothetical. That's not hypothetical. That's kind of real discussion that's kind of going off around the space. So kind of back to where I started with the robots in the cage. Is AI going to come and take all of our jobs? I mean, I think we can kind of take it as a given that actually that's a fairly unlikely scenario because of the productivity paradox, because of how complicated it is. So I think we can focus on the more kind of nuance. So how do we work with AI? How do we get inside the cage with it? Because that's what we're talking about in knowledge work. In AI in the workplace, we've got to work with it. And it can do some really good things. But the issue is that it's a social thing. When we start using AI, it changes the behaviors in the business. And so actually, the bigger thing's not the algorithms, Google's given us one for free, is that actually when we start using AI, it changes people's behaviors. My kind of finishing thing to kind of lead into the discussions, anybody come across the Cobra paradox? So sometimes it's called the rat paradox. I think there's different versions of the story. It's a very simple one to illustrate the point of what happens in business when you start to change behaviours. So allegedly, the British Empire, in India, there was a big problem with cobras. And so what they did was they put a price on the cobra's head. You bring us to Cobra, we'll give you this much money. Eradicated most of the Cobras, massively effective. And then of course the entrepreneurs are like, yeah, they build Cobra farms. It's what they do. It's like, this is good money. I breed Cobras, I take them to the Brits, and they give me a whole bunch of money. This is fantastic. Real example, there is this issue, and you'll be familiar with it yourself in the business. If you set an objective or a target, what happens around that? Right, people game it. And so, again, back to the simulation. If you change the system, the simulation stops working. And so what happens is, again, finishing off, the productivity paradox. When we put technology in, when we bring in AI, people's behaviour changes and adapts to the AI being there. And we get very unexpected results. And that's really the kind of thing that we've got to battle with over the next decade, is what happens as we start to work with computers inside the cage, as it were. Where do we start to delineate between who's making the decision? Because some of those decisions in business will be life or death ones based on AI. At what level do we let it have control? And then the other one is it changes us and it changes our behaviours. What does that mean for us in the workplace and what happens?
Thank you very much indeed. Great stuff. Got me thinking. What we're going to do, what I would suggest, first of all, is that you all get yourselves another drink. And or take advantage of the facilities. And if you're not doing either of those, you can help me put the chairs into a bit of a circle so we can get round to start off a discussion. Yeah? So if we can all be back here in 5 minutes, that would be a miracle. but I'd like us to aim. But I'd like us to aim for it.
Make it so.